Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Grignard reagents react with nitriles to give ketones after hydrolysis. Moving on to the next step. Identify the transformation. PHCN, benzonitrile, must be converted to PHCOCH3 acetophenone. This requires adding a methyl group and converting the CN to AC is equal to O, net result being insertion of a CH3 group on the phenyl ring. Equivalently, the nitrile carbon becomes the carbonyl carbon and a methyl group is added. Moving on to the next step. Reaction of PHCN with CH3NGBr. The Grignard reagent, CH3NGBr, acts as a nucleophile and adds to the electrophilic carbon of the nitrile group, CN. The nitrogen lone pair attacks magnesium, forming an imine magnesium salt intermediate, PHC, is equal to NMGBr, CH3. And for the final step, hydrolysis. Upon aqueous workup, hydrolysis, the imine salt, PHC, is equal to NH, CH3, is hydrolyzed to give the ketone PHCOCH3, acetophenone, and NH3. The C is equal to NH is converted to C is equal to O. Why other options fail? Option B. I2 now H is a haloform reaction condition and CH3I is an alkylating agent. These do not convert a nitrile to a methyl ketone. Option C. DIL. H2SO4 hydrolyzes PHCN to PHCOH, benzoic acid, not to PHCOCH3. Subsequent reaction with CH2N2, diazomethane, would give the methyl ester PHCOCH3, not the ketone PHCOCH3. Option D. LH reduces PHCN to PHCH to NH2, benzylamine, an amine, not a carbonyl compound. Subsequent CH3I would alkylate the amine nitrogen, not give the ketone. Therefore, the correct answer is A. Therefore, the correct answer is option A.